So we can build on this diagram that we have because we know how to make force balance winds. We have a high and a low relative to each other, and that's all we need. We know our ingredients already. So we can start at the equator, again, the easiest place to start. Find our relative high and our relative low. Same up here, the 30 is high and the equator is low. What we're gonna do is our PGF always goes from high to our relative low. Though in the southern hemisphere, our Coriolis deflects us to the left, and in the northern hemisphere, our Coriolis force deflects us to the right. So here in the southern hemisphere down here, we're gonna start with our relative high, and our PGF would like to go straight towards the equator, but in the southern hemisphere, we're pulled towards the left and deflected this way. So we could fill in our arrows here for our surface wind. Same with the northern hemisphere. If we start at the relative high, our PGF always wants to go from the high to the low here at the equator, but we're deflected towards the right in the northern hemisphere, recall relative to the PGF itself. So we'd have to be like standing here at the high and looking towards the low, find the right, and our winds are going to be deflected this way at the surface between 0 and 30. These winds between 0 and 30 on either side of the equator are called trade winds. Next, we can move down to the 30s. Our relative high is here and our relative low is down here. In the southern hemisphere, we get deflected to the left from the PGF. So our surface winds are going to look like this. And then in the northern hemisphere, going from our relative high to our relative low, we're deflected to the right. So our winds are going to look like this at the surface. And these are called westerlies. As are these. Lastly, we can fill in our last polar cell, the surface winds there. Going from our relative high to our relative low, we get deflected to the left in the southern hemisphere, so our surface winds are going to end up looking like this. So we can fill them in accordingly. And then in the northern hemisphere, we've got our relative high at the pole and our relative low at 60. We get deflected to the right in the northern hemisphere, so our surface winds are going to look like this. And these are called easterlies. Because we name winds according to where they come from. So these winds are out of the east, so we call them easterlies, and then these winds are out of the west, they're called westerlies. The trade winds, we call them that because they were very important for trade in the 1700s, how England got to America and exploration and everything, so we call those the trade winds. The last thing we can add on this diagram, we can add some weather in based on what we know about rising and sinking air. We know that sinking air, based on our upper air highway model that we talked about previously, sinking air is going to create sunny skies because when air rises, it's going to cool, condense, expand, it's going to make clouds. So rising air will be associated with clouds, and sinking air is going to be associated with sunny weather.